In our previous video, we looked at the route we actually took as we walked around using the data from our smartwatch and, the activities where you say, I'm going on an outdoor walk. It will then track you and create a file which you can export out of your Apple Health and then we can analyze. Well, in this case, we haven't gone on the trip yet. So what we need is a route. So what we can do is we can actually give a longitude and latitude for the start and the finish. And then we can have Python give us a route. And so this is how to do that. Now, in this case, what we're going to do is we're basically going to go from Red Deer College to Mount Royal University, and Red Deer Polytechnic is in Red Deer, and Mount Royal University is in Calgary. So to get this information, one thing that we do is we go into Google Maps, and what we need to do is we need to get the longitude and latitude. So you can get that by right-clicking if you're on your computer, laptop, or desktop. If you right click, you can then take this, copy that, and then you can paste it right into your code. Oops, let's go back to our code. So you can see here. Now, what's interesting to note is that Google actually flips them from the way that Python needs them. So you will need to flip them around once you do get them. In other cases where we pull them from Google Maps, we would actually create them as we turn them into two separate columns, two separate variables, label one longitude, label one latitude, in which case we don't have to worry about flipping them because we have separated them into two variables so we can specify here's the longitude, here's the latitude. And we can see that, for example, in the Voronoi polygon video, what we did is we could pull the information and we just pasted all of it, all the different McDonald's locations into an Excel file. And from there, you can use this code to separate it out and create two variables, one for latitude, one for longitude. And then from there, you can do the graphing with Folium. So check out that video for how to do that. All right, so once we have our longitude and latitude to start and finish, again, flipping those. Okay. Then in order to do the routes, what we need to do is we need to import Folium. That's what we're using for showing our graph, our map. And then we're also going to need our traditional NumPy and pandas that we always need. And then we also need to import requests, import xml.etree.elementtree, and we'll call that ET for short. And from TQDM, we're going to import TQDM. So what we're going to be doing is we're actually going to be calling a source, and here's the website for it. So somebody has very kindly provided the capability to do this route designing without charging us money. And so this one here is open source to allow people to create these routes. And when you are a large company, then you could be paying for access to much more detailed information for your route finding. But it's basically the same kind of process as we have here. All right, so we need to import our packages. We need to set our source and destination. Okay. We're going to reformat we're going to set our start and end in terms of its formatting. Okay. And we are going to use this project osrm.org to allow us access to the routing. And we are going to request from that URL information. And so we can have it start. And what it is going to do is it is going to contact this website and provide the source and destination and then pull back information for us. So it's collecting the route as a JSON. So let's run that. Okay. Then what we want to do is we want to combine the information that we got with the OpenStreetMap so that we can see where it lays out on the map itself. So we're going to go through these different nodes. Now, of course, the thing is that if we are plotting our trip from one location to another, it takes up a lot of bandwidth, a lot of memory if it is tracking every single foot that you're traveling along that map. So what we want to do is not collect every single data point. And so this first piece here is just keeping every third. We speed up the algorithm by kind of jumping along the route. And so you can adjust that if you need more detail. In this case, we're going pretty much a straight line, but if you are actually going to be looking at a more complicated route, then you may want to keep more of the details, but you probably don't want to run it in Google Colab either. All right, so we're going to start with an empty list called route list, and we're going to loop through these different route nodes, and we're going to keep here every third one. And then we're going to create an empty list called coordinates. And then what we're going to do is we're going to go through those nodes, and we are going to go and we are going to pull an OpenStreetMap. So we're doing a request from this URL, and we are then collecting information in terms of that latitude and longitude along our path. So let's run this. So depending on how far away we are going on our route, this can take longer. Again, you can speed it up by changing this number 3, making it bigger to make it go faster. It'll skip along your path, making it lower if you want more detail. So we will give it a second to run. And what it is doing is it is outputting coordinates in that path. So what we have done is twofold. The first one was to find the best route. And the second one then was to collect our longitude and latitude along that route. And so that's what we're getting here in terms of the information. So I'm showing just here the first 10, but there's quite a number of them, and how complicated the path is, how far away it is going to give you a much longer set of coordinates. Now what we're going to do after that, once it's done compiling, is we are going to then plot our map. And so here we're going to make the location equal to coordinates. And so that's going to be this piece here. In the coordinates, it's going to be the first set of information, so it's index 0. We can set the zoom start again. The higher the number, the more zoomed in your graph. The lower the number, the more zoomed out you are. So depending on how far you are traveling that you're looking at this route, if it's quite a distance, then make your zoom start a lower number. And if it's a small distance, make it a higher number. All right, so it has finished. So if we are to look at the coordinates here, we can see that for the most part, at least for the very beginning of this, we're basically going in a straight line. All right, so let's make our graph. So we start with the base graph. It's going to be the location of these coordinates here, starting with the first one. So remember, this is the center of your graph. So it's just starting with that first coordinate so it knows where to hang out. And then from there, it's going to add all these other locations. And we're going to do that with go. We are going to add our circles, and we can make it whatever color we want. And what you can see here is it's taking the points that it created, and it's showing how we would go from Red Deer Polytechnic, which is right here. You got to leave the campus, you got to get onto the highway, and then it's tracking along the highway. Let's zoom out so we can see where we're going. Move it up a bit, zoom out. Along the highway, down the highway south, we go down to Calgary. And then once you get into Calgary, you can see that you get off the main highway, you turn here and headed into Mount Royal University. So you can see how it has created a route for us, and all we had to do was give it longitude and latitude. And it does this by first collecting a route, attaching to it a longitude and latitude, those coordinates, and then we put it on a map with our data points. So I encourage you to give this a try. Select 2 locations. It's the wrong 2. How about a 2 with a W? Select 2 locations starting and ending. Get them off of Google Maps. Right click. Remember, you need to flip them to make this work. And then use the code that we just went through to see if you can plot a map to it. If it is quite far away or complicated, remember you might need to up the number of skips that we saw in the code that was currently collecting every third. But you might need to change this number 3 to be even bigger if it's quite a distance away.